Okay, so now we're going to talk determinants. Determinants are calculated for a square matrix. Oops. So only like 2x2s, 3x3s, 4x4s, all of that fun stuff. Only those will have determinants. If you have a rectangular matrix like a 2x4 or a 3x5, those will not have determinants. A determinant is also a single value. So when you calculate the determinant of a matrix, you will get a single number. That number can be really large, it can be really small, it can be positive or negative, but it's just a single number. The uses for matrices, or excuse me, determinants of a matrix. Okay, so the first use will be solving systems, which we'll see in a couple of lessons, not today. Okay, finding the inverse, which we'll start talking about that in the next lesson. And then the application we're going to do today is we're actually going to give you yet another way to find the area of a triangle. Okay, so I'm going to show you how to do this by hand. There is a way to do it on Desmos. We will go through that in another video. Okay, all right. So we always start with a square matrix. Okay, we're going to start with 2x2 because the 2x2 calculation is slightly different from the 3x3. Now, I'm only going to show you 2x2 and 3x3 by hand. Anything larger, like 4x4, 4x5 by 5, we're going to let the calculator handle. Okay? All right. So, when you are asked to find a determinant, what you will notice, and I'm just going to give you a general formula here, is that the brackets around your matrix become more like bars. So that is a visual indicator that you are going to be finding a determinant. Okay, so what you're going to do is you're going to take what's called the main diagonal, okay, which is the upper left down to the lower right. So this is the main diagonal. Okay, and you're going to multiply those two numbers. So you're going to go A times D. Okay, then you're going to take the minor diagonal, which is the lower left up to the upper right. And then you're going to multiply those two numbers. Okay, to find the determinant, what you're going to do is you're going to subtract those. You're going to go main diagonal minus the minor. Some students like using the letters A times D minus B times C. and then we're done. Okay, so let's do that with numbers instead of just letters. So we're going to go main diagonal. So negative 10 times a 2, negative 20. Minor diagonal. You get 3 times 5, which is 15. Then our determinant is going to be the main minus the minor. -35. And that's it, you're done. Okay, so let's try another one just to be on the safe side. And just for fun, I'm going to make it fractional. Okay, now sometimes I don't like the circles because they're kind of messy. So what I'll do is I'll just draw a line. 2 times a -5, that's a -10 for your main. 3 times a 1/9, that's a 1/3. So we're going to go main minus minor. So we get -10 and 1/3. And that's our determinant. Okay, another way to think about it, and it might be a little easier for you when we get going on the 3x3, is think of it as bottom minus top. Okay, that's kind of a little easier to remember because I always get confused of who's my main, who's my minor. It gets a little confusing sometimes. Okay, let's talk about 3x3. Now, unfortunately, with a 3x3, we can't really just, crisscross it like a 2x2. So it does take a little bit of prep work. So this is going to be a little confusing just because of how we have to do it. Okay, so here's my matrix A, and here are my 3x3 entries. Remember, we do row by column. Okay, so the first thing you're going to do when you want to find a 3x3 determinant is you're going to rewrite the first 2 columns. Just literally copy them over. Okay, so first step, rewrite first 2 columns. Now what that does is it makes it a little easier to calculate the diagonals. So second, we're going to calculate the diagonals. And we're going to do the main first. Okay, so what you're going to do is you're going to multiply all of these diagonals. See how you catch everyone now? Because you rewrote it, the first two columns. So again, this is going to get a little messy. So we're going to multiply A11 times A22, A33, 3. Then we're going to multiply A12, A2, 3, and A3, 1. And then we're going to multiply A13, A21, A32. Okay, see how I caught all of them? Okay, so now what we're going to do is we're going to add them up. Okay, so this will be your main diagonal right here after you add them. Okay, now we're going to do the minor diagonals. So we'll start from the lower left and go up. Okay, so A31. Then we're going to multiply. And then we're going to add. And these will be your minor diagonals. Okay, and now once we get all of that, we're going to go main diagonals minus the minor, just like before. I forgot to write down our steps. Okay, now I will tell you, when I first started to do this, I would always get confused on who was the main and who was the minor, so I always did bottom minus top. It was just easier. Okay, so let's try one. Okay, this is a heck of a lot easier when you have numbers in it. So I'm going to keep the numbers relatively small. I'm going to keep them positive, but since you're doing like 3 numbers multiplied together and then you're adding, these numbers can get a little bit large. So you might want to keep a calculator on hand. Okay, so we're going to calculate the determinant. Okay, so first step, rewrite just the first 2 columns. Okay, colors are helpful. You don't have to use them. Okay, then we're going to do our main diagonal, and you can do this in your head if you can. 1 times 5 times 6, that's 30. 2 times 7 times another 2, that's a positive 28. 4 times 3 times 3, that's a 36. Then we're going to do the minor diagonal, 2 times 5, which is 10 times 40, or 4, which is 40. 3 times 7 times 1, which is 21. 3 times 6, 18 times 2 is 36. Okay, so 40 plus 21 is 61. 61 plus 36 is 97. 30 and 28 is 58. 58 and 30, 58 and 36. Oh dear. Let's just be careful. 94. So major minus minor. And we get a -3. And that's it. Okay. All right, let's try another one. Let's throw some negative numbers in there. Okay, so I did a couple things that we didn't see in the first example. What I did is I threw a couple negative numbers into the matrix and I threw a 0. Okay. Okay, first rewrite. Okay, make sure you have all your negatives and all the numbers in the right spot because that is kind of a thing. All right, so we're going to do major diagonals first. -3 times a 0 times a 2, that's a 0. -4, or excuse me, -1 times a 4 is -4 times a 1 is a -4. Let's see, that would be 160. Because -8 times 2 is -16 times a +10, that's a +160. Cool. All right. Now let's do the minor. That's a nice 0. +120. And then 2 times 2 is 4 times a -4. Okay, so add them all up. Okay, then we're going to do bottom minus top or major minus minor. And we get 40. And that's the determinant. Okay? All right. So now what we're going to do is we're going to do one example of an application. Okay, we are going to find the area of a triangle. Okay, and then we'll also begin to talk about systems too. Okay, so I am going to graph a triangle on an XY axis. Okay. Okay. So what you're going to do is you're going to find the vertices of the triangle. So let's see, 1, 2, 3, 4, 5. So -5, 1, and then 2, 2, 6. Okay, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 4. Okay, so what you're going to do is you're going to write a matrix. Okay, and that matrix is going to look like this. Oops. And it's going to have ones, believe it or not. Okay, so our vertice matrix will look like this. Okay, so that's our vertice matrix. So to find the area of the triangle, we're going to use this formula right here. We're going to go positive and negative 1/2. Okay, and then we're going to find the determinant of our vertice matrix. So you're going to do a determinant, and then you're going to multiply it by a scalar of 1/2. Okay, so let's do it. Okay, and the reason you want a positive or a negative on that 1/2 is because sometimes the determinants will come out negative, and area can't be negative. So once you figure out your determinant, you decide what sign you need. Okay, so I'm going to go ahead and find the determinants separately, and then I'll plug back in. So again, this is a 3x3. So we need to rewrite those first two columns. Okay, here we go. Major minus minor. Okay, here we go. So now since we have that determinant, okay, we have a negative determinant. So we're multiplied by a negative 1/2. So 1/2 of 49. My area is 24.5 units squared. Okay, so that's how you use determinant to find the area of a triangle. Okay, I hope this was helpful. Okay, and then we'll talk about the linear systems and how determinant applies to that when we get to that section of the lessons. Okay, I hope you have a great day.